In this third segment on quality function deployment, I'm going to talk to you about the last few steps in developing the house of quality. And we'll begin with the customer perceptions, or what's also called the qualitative benchmarking. And this is recorded over on the right side of the house of quality, where you record the degree of satisfaction of the customers with respect to, in this case, in your case, your current product that you're redesigning, as well as benchmark products. And so it's usually done on a scale of something like 1 to 5, 5 being highly satisfied, 1 being unsatisfied. And so you can see there's a ranking for each customer need and for each of the benchmark products. And so for your project, I want you to do this too. Ideally, what you'd do is, if you had the competing products, you'd put those in front of some of your customers and ask them to give you those rankings. However, I realize that may be difficult. You may be able to do some of that if you have competing products in your possession, or if the customers do. But I'm not expecting everyone to have access to those. So I think the best thing you can do is to look at online reviews of competing products and base your understanding of the customer's perceptions of those products on those online reviews, and we'll see what you come up with. So that's that. Normally, what a company would do was probably, in this case, since it's an automotive company, probably what they did is put together a focus group, and they actually had the competing cars there as well as their existing car, and asked the customers which one's easiest to close, which one stays open on a hill better, etc. So they do that. That's a good thing to do with a focus group. But I'm not expecting you to do that, as I said, and so to the extent that you can, do this qualitative benchmarking using resources that are available online. Now, the next step in the procedure for house of quality is to test and measure the actual values of the performance parameters for the competing products, and that's recorded down here at the bottom of the house of quality. And so you can see for each of the performance metrics up here, the value for each product, including the product that's being redesigned, is recorded for each parameter. And this will be used later on, we'll see, to set the objective target values, or object target values, which are the target values you're going to shoot for in your redesign. So that this information plus the qualitative benchmarking gives you a basis. As I said earlier, that's a rational basis for setting the target values. And again, this may be difficult for you to do for your project, and I understand that, because it'll be it'd be a lot of work to actually measure all these parameters for all the products that you would benchmark. You should be able to measure at least some of them, actually measure them for your product that you're redesigning. And you'll want to do that anyway, most of you, because that would be the basis for a parametric redesign, at the very least, would be to measure those parameters, and then say in an analytical model, or maybe even a physical model, to test whether you've improved those or not, or to analyze whether it's possible to improve those. So you'll want to know what some of those values are, just for verification. Others, though, you can take off of spec sheets, both for your product and for the benchmark products. Many product websites will have a tab in the product details that is called specifications, and so you should take that information. And for the purposes of this project, just assume that the manufacturer has put up correct specifications. If you are actually doing this in a competitive situation where you're expecting to make money on it, where you were banking a company on this product redesign, you might want to verify what the vendors are putting up there. But for the purpose of this project, I think you can rely on what's available to you on the web. Okay, the next step in the House of Quality is to complete the roof, which is very interesting to me. And it's where you record the second main purpose that I gave you at the beginning of this unit on quality function deployment, which is to record the relationships among the performance metrics. And this is important because in many cases you have to do trade-offs to try to get the optimal performance out of a product. We're also going to use this information later on in concept generation. I'll present a concept generation technique that is specifically targeted at addressing conflicts among performance metrics. And so we'll see that meshes well with the House of Quality. But if you look at it, you can see that it is it's another matrix, and the symbology is given up here. If you look at different examples, you'll see various alternatives for the symbology. In this case, I've used positive and negative, or plus or minus to represent positive or negative, and then a plus sign with a circle or a negative sign with a circle means high positive or high negative. And so the way to read this is there's a cell in the roof for each pair of performance metrics. So if you look at these first two, say torque to close door, you go up, you go to this cell, and then you go down, and it's closing force. And so that cell represents the relationship between torque to close door and closing force. And in setting up the correlation matrix, you need to take into account the arrows or the directions for improvement for each of the performance parameters. Because from a physical standpoint, torque to close door and closing force, there's a positive correlation there, right? Because if you increase the closing force, you're going to increase the torque to close the door, or vice versa. If you reduce the closing force, you reduce the torque to close door. So from a physics standpoint, this is a positive correlation. But from your standpoint, from the design standpoint, you have to account for the direction for improvement. So in this case, we want the torque to close door to be reduced because we want it to be easy to close from the outside. And so that's that relationship. But for the customer needs stays open on a hill, we want the closing force to increase so that it's harder to close the door. And so that represents a conflict. And so that's why there's a high negative in that cell. And so there's a pair, as I said before, there's a cell for each pair of performance metrics. So if you go up here, and go down there, you can see that those two are related. So that's closing force on a 10-degree slope and acoustic transmission, and they're correlated in that cell. So that's the roof of the House of Quality. Now, there's two other pieces of information that we want to talk about, and these are in the bottom of the house, and so I'll show the next slide that shows those. The first is setting target values, and that's done down here. And these are the target values you're going to shoot for, and this is done by reviewing information over here in your qualitative benchmarking plus the objective measures where you measured the values, the performance metrics for each of the competing products as well as your own. And so here's an example. So torque to close door. So you can look at the qualitative benchmarking, you see that the two competitors did pretty good on a 1 to 5 scale. They got 4 out of 5, whereas the existing car, our car, did rather poorly. It got a 2 out of 5. And so the team has to ask themselves, okay, if we want to improve, how much do we want to improve? So you look at what the current values are, and you can see that you focus on the parameter that is strongly related to that customer need. And so you see that in this case, the two competitors are 9 and 9.5 foot-pounds respectively. So significantly better than 11 for our car. And so you ask yourself, do we want to be as good as our competitors? And if you're willing to accept being as good as, you might set the target around 9. But in this case, the team decided we want to be much better. So we're going to shoot for something that's better than the competitors, and we're going to shoot for 7.5. So that's what I mean when I say it gives you a rational basis for setting those targets. It's based on customer perceptions as well as objective data that you measure. So that's how the targets are set. The last thing in the house of quality is to set the technical difficulty and technical importance of the performance metrics. And so the technical difficulty is, again, is recorded or rated on a scale of 1 to 5. So 5 is difficult, 1 is easy. And that is done by team consensus. And it's not particularly easy to do, but it's based on the team's judgment and rationale on and their experience based on how easy or how hard it'll be, given an understanding of current technology, how hard or how easy it'll be to achieve the target that you've set for yourself. So that's technical difficulty. The last piece, technical importance, this is the only thing that's automatic about the house of quality. And so the absolute technical importance is based on, this is where we use the weights for the relationships. It's based on multiplying for a given parameter, multiplying the weight the customer need times the weight of the relationship, and summing those up in a column. So in this case, there's only 1, so it's 45. In this case, you can see it's 5 times 9 plus 2 times 3 plus 2 times 9 plus, and I don't remember those 2, or it's 2 and 1. 2 times 9 plus 2 plus 1 times 3. So you add all those up, you get 90. So that's where that comes from. And so that can be programmed in if you do this in a spreadsheet, or there's also software that's used to record a house of quality, and those will typically do that calculation for you. But that's all that is. It's if you remember your vector calculus, it's a dot product between this column here and this column here, say, that gives you the 90. Then the last row down there, the relative, is just an ordinal ranking of those. And so the highest is ranked 1, the next highest is 2, etc. Now, how do you use that information? Why do you need to know technical difficulty and technical importance?